So what do you do when your breaker trips? You see that breaker trip. When it goes back to the center like that, that breaker is tripped. All the way off, all the way back on to reset, trip. So how do I diagnose it? Stay tuned, friends. All right, so you find that your breaker is tripping. How do you fix it? What do you do? What do you go about? One of the first things we can do, this is a control pack. This is the heater in the pack. I suspect the heater is bad, but I don't know that for a fact, so I'm going to show you how to figure it out. The other thing that you would do is if your tub was equipped with a blower, unplug it first. You'd simply just grab it and unplug it from the board. Try to reset the breaker again. If it doesn't make any difference, then go to the next thing, which would be an ozonator, which would be a little ozone device that's plugged in. And usually on the board, on the side of it, on the pack, it'll be written on there, or you can look on here and it'll actually give you an indication. This particular tub does not have a blower. This particular tub does not have a ozonator, so I don't have those to unplug. The other thing you could do is go ahead and make sure you mark everything. This is a circulation pump, 2 jet pumps. Just simply unplug each item from the board, from the pack like this. Keep saying board, meaning pack. And then go try to reset the breaker. So I'm going to go try it. I'll be right back. So I tried that and it still did not set. It tripped just like you saw previously. So I'm going to plug all this stuff back in. That way I don't lose where it came from. Put everything back where it came from. And make sure you've marked it. I know where these go, so I've got little marks on them. So I know exactly where they go. And so next we're going to go to the next thing, which would be the heater itself. Now the way I'm going to do that is I'm actually going to isolate the heater from the circuit. The way I'm going to do that is I'm going to take my wrenches and I'm going to undo the nuts and pull the wire tabs off of the heater itself. Try to see if the breaker will set. If it will, then the heater is bad. If it will not set, then we got to go on to plan B and see what else there would be. Other things that would cause it not to set is improperly wired, miswired, wires touching, and especially if the tub's, some of the clues are this: if the tub has run for a while at your house, if it's been there for years and years and years, or even a year running, then it's not likely that you have a GFI issue or a wiring issue or something of that nature. If you just wired the tub up and it will not set, then it's possible that you've got the GFI wired wrong, or you've got something hooked up wrong. The other thing is, some tubs, this tub has a transformer made on the board. Some people will unplug the transformer, the breaker will set, and they'll order a transformer thinking that's bad. Never seen a transformer bad. I've got 7,000 tubs that we service, never seen one bad. Not on a Balboa or a Gecko. I've seen one bad on a Sundance tub one time. So that is never going to be the answer. It'd be so rare that it was not even worth talking about. Transformers out, basically. So the other thing would be is if you can't figure it out in the normal diagnosis, the things that I'm going to tell you right here, then it's probably man-made. So that means it's something that somebody did to the tub. It could be that one of these is plugged in the wrong place, got a wire pinched in this little collet. There's a lot of other things that will cause it, but they'll usually show themselves as far as it'll make a little burn mark there, or you'll see something like that. So I'm going to go ahead and unhook this heater, show you how to do that. We're going to see if it'll set. If it will, then we're going to change the heater out, and I'll show you how that works. Stay tuned, friends. So what I'm going to do is, some of them have a 1/4 inch on the bottom. This particular one has a 1/4 on the bottom. Some of them have a 3/8 on the bottom. So I'm going to hold it with the 1/4, and I'm going to take the top one off with the 3/8. The reason that you hold it is you don't want to twist that electrode off in case the heater is not bad. If it's not bad and you twist the electrode off, guess what? You got to have a heater. So I'm going to get both of these loose. It's a very simple test. And of course there's no electricity here. Now once you've powered up, if you touch here, there's 115 volts on each one of these legs, so of course it can shock you. So be careful, friends. If now I do have a little bit of a clue. If you look right here, if you look around that, it looks a little bit rusty right around the edge of that. So I suspect that leg is leaking, and what happens is it leaks up from the bottom and it'll leak through where the epoxy is on the inside, and it will cause issues. So stay tuned, friends. We're going to see if the breaker sets. So you did hear the breaker set, and you did hear the pumps come on. I suspect then that well, I shouldn't say I suspect. I know for a fact that the heater is bad, but I'm going to show you here another test. This is another way that you can try to eliminate it. I really don't recommend that you do this, but I'm going to show you that it will trip the breaker. You can hear the pumps running. I'm going to turn a jet pump on. So watch what happens. You can hear these pumps running. Watch what happens when I touch this back. You hear it trip the breaker immediately. So this heater is bad. So stay tuned, friends. I'm going to show you how to change it out. All right, so this is what a new heater element looks like. You can see that it's got two nuts that are 3/4 or 19 millimeter. It's got two 3/8 nuts on the top. So we're going to take this out of this tube. Now the way we're going to do it is I'm actually going to remove the tube from it. But before we do anything, that's 5/16 the size of the nuts that are up in there. Before we do anything, we've got to isolate the water because I'm not going to take the water out of the tub. The way I do that is there's some, I call them slice valves. And you can see here that you've got an inlet side of the heater and there's a valve right here. Actually, that's the outlet side of the heater because it pushes through. So the way you do that is it's got a keeper on it. Remove the keeper, push it in and twist it. And then you could see that there's one way back there. So the way I'm going to reach it is I'm going to reach through here, pull that off, twist that in there, and turn it. Now there's a good possibility that this thing is not going to hold water. And what I mean is those slice valves are not going to hold. So we're going to hope that they hold and give us enough time to do it. The other thing we've got to do is there's a bleeder on the front of this pump. You see this bleeder right here? If you don't pinch this hose, you're going to get water the whole time. So I'm going to get a pair of needle nose vice grips and we're going to clip that hose right there. Stay tuned. All right, I found that when you're pinching these hoses, if you pinch them at an angle, it actually does a little bit better stopping the water rather than just a straight pinch. And I'm going to, for purposes of this video, I'm going to pinch this thing twice just to try to make sure we don't have much water. There we go. I'm going to go ahead and get some other stuff taken care of here, like these sensors. So you can actually tell if you're going to get any water from these sensors. And I'm going to go ahead and relieve the pressure here real quick. See if we're going to get much water. We should get some, but if you ever loosen a nut like this and you hear the water just gushing, then of course look for a air bleeder like we looked at. If you can't find an air bleeder, then your slice valves are probably just not going to hold. That happens. And when tubs get some age on them, let's see, we're still getting a lot of water. So my slices are not gonna hold very well here, I don't think. Yeah, you can see that side's still gushing. So that slice is just not holding very well. So we're going to, I'm gonna pull the water down real quick. Stay tuned. Now, if you're at your home and this thing's outside, it's not a big deal to do this, but this thing's inside, so I don't want to flood the shop. What I'm going to do is I'm going to undo my M7 sensors and leave them plugged into the board. That way you don't have to deal with trying to get them plugged in. Now, some tubs don't have M7 sensors. They're going to have a pressure switch, like the Gecko style packs are going to have pressure switches. Alright, so I got my two bands off. Now the tube is loose. I can pull it out. So what I'm going to do is pull the M7 sensors out. And sometimes these things are a little stuck. You don't want to damage the sensor, but you can put a little bit of pressure on. There you are, friends. And this is not the ideal tub to be doing this on because some idiot put this right here directly in front of the pack. But that right there is what the tube looks like. And you can see on this label, this particular one is a 5.5 kW. And this element fits inside of it, and it'll look just like that right there inside of the tube. Now another thing is, if you look in the tube, down in the middle of it, you'll see that the element is not touching the sides of the tube. That's critical. You do not want it to actually touch the inside of the tube. Actually, this one is touching. You see, they didn't line it up. I always line mine up because what will happen is it'll create a hot spot right here where it's touching. So the next thing we're going to do is take a 3/4 inch wrench or 19 millimeter, whichever one you have, and you simply turn the two nuts off. And this one, we're going to see some rust around one of these electrodes. It's going to be this left one right here. I can actually see it on the outside. So what you do is take something, just kind of tap it out like that right there. And then you can, a lot of times I'll take a flat screwdriver and push the element over, hold it with my fingers inside, push that next one, that next electrode down in the hole, and then you can kind of slip it out. And because of the M7 sensor right here, you have to do it at a little bit of an angle. So there you go, there's the old one. And if you look right around there, you can see rust. That is an indicator that it was leaking through. What it does is leaks through here, through the back. So we're going to put a replacement. Now I use titanium heaters. This is an Incaloy, which is the standard style. I don't do that. I use titanium, which is resistant to salt and other things. It's not impervious to it, but is resistant. And by the way, chlorine is a salt derivative, and sanitizers almost all are based off of salt. So what we're going to do is take these two nuts off. I'm going to take the two big nuts off. And if you notice, there's little O-rings right here. Make sure your O-rings are in place. I use silicone. I do not put them in without silicone. And the reason, I'm going to go ahead and clean my tube up first. Let me show you that real quick. The reason I use silicone, you can see this rust right here. So you want to clean that rust up. Get it nice and clean. And look, there's times when you're going to have to actually hacksaw the nuts off of the heater because the epoxy part, this part right here will actually spin. And you don't want it to spin on there, so I'm going to look inside and see how it looks on the inside. It's got a lot of stuff in there too, so I'm going to clean it up with this, with my wire brush. Clean it out nice. Alright, I got that clean. So now I'm going to take my silicone, I call it the Professor Silly Juice. I'm going to put just a little bit around the threads, right around the O-ring here. Not much. Like that right there. And some tubes are tighter than others, but the way I do it is I'll turn my tube a little bit sideways, so I'll put it in there sideways based off of where the M7 sensor is, and you can see this one's going to fit through very easily. Do like that. Just pull it through, and once I pull it through, I've squeezed my silicone, so I try to hold it in place and not let it go back through. Tighten that one. Tighten that one. If you ever have to cut the nuts off with a hacksaw, the way I do it is I'll take a pair of pliers and break the electrode off and cut directly across the center, and it splits the nut half in two, and it'll pop off, and then the other part will push through. So now I'm going to hold my finger inside the heater like this to keep it off that wall, because when you start tightening, it's going to twist towards the front of the tube. So we can line it up. Your finger will give it that space that you need. It doesn't have to be crazy tight, but what you'll do is you'll go ahead and tighten it like that. Hold your finger in there, and then just back off of it a little bit and line it up, and you can see that it's directly in the center of the tube like it should be. Now that is a properly installed heater element. Wow. Alright, so you slip your M7 sensors back in, push them all the way in and tighten them up. Just tighten it with your fingers. You don't have to do that with your hand. And while I've still got room here, I'm going to put my gasket in. We have these gaskets in our store. If you think you need them, if it's been a while, not a bad idea. These gaskets actually still look really good, but the chemicals will eat your gaskets up. So if it's been a while, you don't want to take a chance, because when you disturb this, especially if a gasket's got a split in it, you're done until you get a gasket. I'm not going to tighten this until I get my bands on. I don't really tighten anything up until I get everything in place. And there's times that you wouldn't even have to take the tube out if you have enough room on this side to slide it out, and have enough room on this side to get your fingers up in there to tighten it going the other way. This particular tub, we didn't have that luxury, so that's why I did it like this. Alright, so now I'm going to tighten the nuts here on the heater, being sure not to move them. Don't let it twist the electrode. If you don't hold it, some of them, like I say, the bottom is going to be 3/8, some of them are going to be quarter. This particular one's quarter. And I have had to actually file a wrench down, make it thinner to make it fit in between. I've probably installed more than 1,000 heaters. Put a bunch in. It's a simple thing. Just make sure, of course, it's powered down. But in most of these cases, the breaker won't even set if the heater's bad. Now that's the other thing. Let's talk about that. Is your heater bad if the tub won't heat? The answer is rarely. If it's a no heat issue and you've got a red light on the board and you check across these and you have a reading, I'm going to show you. We're going to test across it real quick. So if you check across this and you have a reading of about 10.5, 10.6, you see that was reading 10.5, 10.6. So that is a good heater. You should be able to measure from here to ground and not hear a beep. Measure across it. If you have a 4kW, it's going to be a little higher reading. It'll be in the 15. And what I've got it is K ohms. So it's in the ohms reading. And it was about 15.5, 15.6, which is a good heater. So lastly, I'm going to take my oil filter pliers and I'm going to snug this side. Since I've got it locked down, you don't do it before you lock the tube down. Alright, so I'm going to fill it back up, and then we're going to open the slice valves. One of the keys is, if you open a slice valve, service valve, gate valve, whatever you want to call it, if you open one of these valves and you hear air coming out, you've got a leak. So just go ahead and stop it, find your leak, snug everything back up, check your gaskets, that kind of thing. So stay tuned, friends. Alright, so I've got the tub back full again. So what I'm going to do first is take my bleeder holders off. Next, I'm going to open my slices and listen for air. No air coming out. Now you're going to hear air inside because the water is coming into the heater tube. And so I've opened that one. I'll reach in the back here and open the other slice. Now, friends, I'm going to go turn the breaker on, and you should hear her fire up with this. Turn this on so you can see it start drawing. Actually, right here. There's the amperage. You see the circulation pump came on. We'll bypass the PR mode. So now we're going to watch for our heater to do a test fire. And what that test fire will be, it will temporarily fire the heater for about 8 seconds to determine on this M7 system. Now this is only M7. If it's a pressure switch system or a Gecko system or an ACC or another brand, this is not going to happen. If you have this system, this is going to happen. What it does is it's got to calibrate between these two sensors. So it's actually going to do a test fire for about 8 seconds to heat the heater, and what it looks for is a temperature raise between the two sensors of about 3 degrees. If it doesn't have 3 degrees, then it's going to think there's not enough water movement. It takes about 25 gallons per minute, and it's going to actually give you a flow code or a DRY code or a DR code of some sort. But this one appears to be flowing good. I can put my hand on the tube. Another thing is when you put your hand on this tube, it should be the same temperature as the water in the tub, not hotter. If it's hotter than the water in the tub, there's something wrong. There's the test fire. Let's see, it's about 19.5, and it's actually a hair more than that, but my amp clamp is a little worn. It's going to be about 20.5 about on a 5.5 kW. 4 kW is going to be about 15.5 roughly, somewhere in that neighborhood. It's doing its calibration. It's going to take a little bit, and once it calibrates, it will go ahead and start heating. Now let's look. I believe we've got a code. See, we've got a DR code right there. Look at that. It's not seeing enough water movement. So what I'm going to do is I'm going to hit the temp up button, and I can see that there's no water movement in here. So what I'm going to do next is I'm going to bleed it. This particular tub has a bleeder right here. So it's actually not moving water. So we're going to take this bleeder plug out. This is just for this brand. All brands don't have this. And a lot of times we'll turn the pumps on. But I can actually hear this pump and tell that it's not moving water. It has a very distinct sound to it when it's not moving water. So a lot of times, in order to get the air out, you have to stop the pump. So what I'm going to do is I'm going to unplug the pump for just a moment, let it settle, see if it'll knock the air out of itself. And it's not doing it, so I'm going to try. So what I'm going to do is loosen the nut. We're going to lose a little bit of water. You can hear all that air in there. Now she's moving some water. Now if you were looking at diagnosing the heater, I want you to see 200, and there's only 203 in here because we're in industrial voltage. If you were at home, it would be 240. So your input, your black and red should be full voltage. Red and white should be half voltage. Black and white, half voltage. And white to ground should be 0. So that is correct right there. If you check across here, your red light is on the top saying that it is heating. You check across here and it's not 240 volts. And it's 0. But you check between here and ground and you get a half voltage, and there in ground you get half voltage, you have a cold solder joint on the board. So there you are, friends. Click the banner across the top. It will take you to our website for all your parts, heaters, pressure switches, parts, anything that you could need for your hot tub, we probably have it. I don't know much, but I do know hot tubs. Click now.